Deep in the Galapagos Islands, a 200-kilogram tortoise stands almost completely still under the morning sun. She's been alive for over 80 years. She's survived droughts, disease, and predators that no longer exist anywhere else on Earth. But right now, she's covered in something she cannot see, cannot reach, and cannot fight on her own. And in the next few seconds, this slow, ancient reptile is about to do something that looks almost impossible for a creature built the way she is. She's going to ask for help.
Giant tortoises can live well past 100 years, and that shell everyone associates with them is only part of the story. The real vulnerability is the skin underneath, thick, deeply folded, wrinkled around the neck, the legs, and the joints where the limbs meet the body. Those folds exist for a reason. They let the tortoise pull its legs and head inward for protection, but they also create the perfect hiding place for parasites. Ticks wedge themselves deep into those creases, in spots the tortoise's own mouth will never physically reach, no matter how long its neck stretches. Over weeks, these parasites feed slowly, drawing blood a little at a time. Over months, that drain adds up. Over years, for an animal that lives a century, it becomes a permanent tax on its health. A tortoise cannot scratch the way a mammal can. It cannot groom itself with claws or teeth the way a cat or a bird can. It carries this burden the way it carries everything else in its life, slowly, silently, for as long as it survives. Unless something else intervenes.
For decades, biologists studying these tortoises noticed something that didn't quite add up. Some individuals carried noticeably fewer ticks than others, even when they lived in the exact same patch of the same island, eating the same plants, moving through the same terrain. If the environment was identical, the parasite load should have been roughly identical too. It wasn't. Something was different about these specific tortoises, and it had nothing to do with genetics or location. It had to do with behavior. Somewhere in their evolutionary history, certain tortoises had started doing something that no reptile was ever expected to do. They learned to signal. They learned to ask.
Researchers eventually documented exactly what was happening, and it's called the invitation posture. When a small ground finch lands nearby, the tortoise begins a very specific, very deliberate sequence. It extends its neck straight up as high as its body allows. Then, one at a time, it lifts each leg slightly off the ground, rotating its body just enough to expose the skin folds hidden underneath its shell. And then, it simply holds that position, sometimes for several minutes at a stretch, barely moving at all. This isn't random shifting or an attempt to cool down in the sun. Scientists tracking these interactions found that the posture appears specifically and consistently when finches are nearby, and it disappears just as consistently when they're not. In other words, the tortoise isn't just tolerating an approaching bird, it's actively signaling to it. And somehow, across an evolutionary gap of hundreds of millions of years between reptiles and birds, the finch understands exactly what that signal means.
The moment the posture is held, the finch hops directly onto the exposed skin, moving with the confidence of an animal that has done this many times before. It works through the folds methodically, plucking out ticks one by one and eating them on the spot. For the finch, this is about as efficient as feeding gets. No digging through soil, no chasing insects through brush, no competition from other birds for the same patch of ground. A meal is simply delivered to it, fold by fold, for as long as the tortoise holds still. For the tortoise, the benefit runs even deeper. Parasite loads that would otherwise persist for its entire adult life get cleared out, repeatedly, every time this exchange happens. Neither animal is doing this out of anything resembling kindness. This is pure biological exchange, refined over an enormous span of time until both sides evolved a shared language neither of them had to be taught. A posture on one end, a response on the other. No sound, no physical contact beyond what's necessary. Just two completely unrelated species,
operating on an agreement that predates human observation of it by who knows how long.
Here's the part that genuinely surprised the people studying this. Tortoises don't simply wait around hoping a finch happens to pass by. Some individuals have been observed moving deliberately towards specific areas where finches are known to gather, well before any bird is actually visible. That means an animal often mocked for being slow and simple-minded may be doing something closer to forming a memory of where help tends to show up and returning to that exact location on its own initiative. A reptile with a brain roughly the size of a walnut, appearing to plan around a service performed by a completely different species. It's the kind of behavior that, in a mammal, would be described without hesitation as intelligent problem-solving. In a tortoise, it still makes researchers pause. This isn't unique to the Galápagos. Nearly every continent has its own version of the same arrangement. Oxpeckers ride along the backs of Cape buffalo, picking ticks from wounds most buffalo can never reach. Egrets stand on the heads of rhinos, doing the same job in a different landscape. Small fish clean parasites from the skin of hippos, submerged and invisible to anyone standing on the shore. But the tortoise version may be the most unlikely of all of them, because everything about a tortoise's basic biology argues against it. It's slow. It's solitary most of its life. It has almost no facial expression, no vocal repertoire, none of the obvious communication tools mammals and birds rely on. And yet, somewhere in its evolutionary past, it found a way to say one simple thing to a completely different species. Come here, I need this. And it worked well enough that the behavior stuck. On one island, researchers began recognizing a specific tortoise they nicknamed Diego, estimated at well over 100 years old, with a shell scarred from decades of exposure and old injuries. Diego performed the invitation posture more frequently and more precisely than almost any other tortoise in the study group, holding position for unusually long stretches in locations that consistently attracted finches within minutes. Whether that came from experience, memory, or simple repetition over a century of life, no one can say with certainty. What's clear is that the tortoise researchers initially assumed was just old and slow turned out to be, in this one specific behavior, more consistent and more effective than tortoises a quarter of his age. The tortoise that learned to ask for help doesn't outlive the one that never did, because it's smarter in any way we'd recognize in ourselves. It survives better because, somewhere far back in its evolution, asking stopped being a weakness and quietly became a survival strategy instead. And across the animal kingdom right now, in places almost no one is watching, that same silent negotiation between two unrelated species is happening again. A signal given, a signal understood. No words, no explanation needed, and somehow it's exactly enough, which is exactly where we're going next.